Good morning, students. So, last classes we discussed the vectors and it is finished. Then we'll go to the next topic called motion in a straight line. So, this is also called as a motion in one dimension. What is motion in a straight line and motion in one dimension means? You can say that if the motion of the body is restricted to move in one dimension, either along x-axis or y-axis or z-axis. So to describe its motion, we need only one coordinate. Then we can say that motion is said to be one-dimensional motion. Or else we can also define like this: if a body is moving, then if you line join the successive positions of that motion, the successive position line joining gives a straight line, then the motion is said to be a straight line motion. For example, if a body started here and it is gone to here and point B, its line joining is a straight line, and here its line joining is straight line, it is coming to here, it is line joining a straight line. Then we can say this type of motion is a straight line motion. Or else we can also say one-dimensional motion. In this, first of all, you have to know what is the reference frame. What is a reference frame means? A frame of reference. A frame of reference means it is a platform from where a physical phenomena such as motion can be described. So it is also called as a reference frame is nothing but a coordinate system. Let us take a coordinate system. Here x, y and z axis. So it is the reference point, origin is the reference point, and in this coordinate system, for example, is this room. This room is can treat as a reference from having the x, y and z coordinates, and a clock is attached to this reference frame. If a clock is attached to this reference frame, we can say this coordinate system, this we can call it as simply a reference frame. Reference frame is nothing but a coordinate system, and along with that coordinate system we have a clock. This is we'll call it as a frame of reference. So now we'll go to the discussion of, suppose, rest and motion. So this rest and motion is what we have, it is relative terms. They depends upon the frame of reference. Now we discussed the frame of reference means the coordinate system having a clock attached with that system. Now we'll discuss what is rest and what is motion. So rest and motion. Here we can say what is rest means. If a body does not change its position with respect to time, then we can say that body is at rest. For example, in this room, for suppose one body is there, if you are counting the time, if its position never changing, it is not changing with respect to time, so we say that body is at rest. Or else in this room, if time changing, I am also moving from one place to another place means so I can we can say that I am in motion. The body does not changes with respect to time, then its case as a rest. If the body changes with respect to time, its position changes with respect to time, is called as the motion. Rest and motion are relative terms. And they depends on frame of reference. Reference. Why? Because suppose if you are sitting in a train, the co-passenger with you are there, and if the train is moving, so you and your co-passengers, they appears to be in motion by a person who is watching from outside. But if you are watching, your co-passenger appears to be at rest, because both are in the train frame of reference, but the other person who is watching from outside is in the other frame of reference. So you are at rest with respect to your co-passenger, but you are in motion with respect to your observer watching from outside. So Motion and rest are not depends on relative terms, that depends on the frame of reference. Next, will we discuss the position vector. What is the position vector means? So in a coordinate system x, y, z, if you have a point P whose coordinates are x, y and z, the vector which connects the origin and the point and which is directed towards the point, this vector is called as the position vector. That is r bar equal to x I cap plus y j cap plus z k cap. So position vector is the vector which connects the origin with the point and is directed towards the point is called as the position vector, and r bar is nothing but we can write as the x I cap plus y j cap plus z k cap, and its magnitude is nothing but root over x square plus y square plus z square. Next we will discuss what is the displacement vector. Displacement vector. Let us take two positions of the particle. So in this coordinate system, it is the point P1 whose coordinates are x1, y1, z1. Next, this is the another point P2, which are the coordinates x2, y2 and z2. Then the line joining the origin to the point is called as this is the position vector r1, and this is the line joining the point P2, this is the another position vector r2 bar. Then the displacement vector is nothing but this change in position. So this is what we can call it as a displacement vector. So delta r bar is equal to r2 bar minus r1 bar. So this delta r bar is nothing but the displacement vector. So displacement vector delta r bar equal to the change in position vector is r2 bar minus r1 bar. Also we can also write this as a x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. So this is we can call it as a displacement vector. Next one we will discuss the what is distance and what is displacement and difference of it. Distance and displacement. If you observe it, in the coordinate system we have two positions. Here position P1 and here position P2, and this is vector r1 bar position vector r2 bar. So this is we treat as initial position and this is we treat as a final position. The particle started motion from the P1 position and it is traveling like this and it again reaches to here. So this is what we can call it as a actual path traveled from the initial point to the final point. This actual path length is called as the distance and it is a scalar quantity. And from initial position to the final position, the shortest straight line path is nothing but we call it as this is the shortest straight line path. This shortest straight line path is called as the displacement and it is a vector quantity. This is a displacement and it is a vector quantity. So here displacement is a positive or a negative or zero also. So why it is positive? When it is positive, in the sense, if you started from the here O is the reference line. If the body start along the positive side, means here to here, this is plus x and it is minus x from 1 to 5. So its initial point to final point A to B is nothing but plus 4 meters along positive x-axis. So this is a positive displacement. But if it is gone from A to B and again it is travelled, from here initial point is A, it is initial point and it is final point during it. Now again the particle started. Now it is not ended at B, again it is travelled to up to minus 8. Then what is the displacement means? We have discussed the display. Now it is the final point is C. This is the final point. So final point, now initial point is here. So final point and initial point in the sense, you see here, from initial point to the final point, how much of shortest distance is nothing but the what? Displacement. Here the displacement is nothing but towards the negative x-axis. It is initial point, now it is the final point. It is how much here is along 1 and here minus side. It is around 9 meters distance along negative x-axis side. It is around 9 meters along which side here? Negative x-axis side. So it is a negative displacement, here positive displacement we can take it. And also zero. Zero in the sense, if from where it is started, again coming back to the same point means there is no shortest distance between the initial and final point, then we can say its displacement is zero. So it is positive or negative and zero. And distance is always positive. And also here we can say displacement magnitude is either less than or equal to the distance. If it is a straight line path, distance and displacement are equal. For other than straight line path means displacement is lesser than the distance. So in straight line path, so we can say here distance or displacement are equal. So magnitude of displacement is less than or equivalent to distance. Next we will be discuss one of the example. Let us suppose we are taken here a circular path. It is started, a body is started from A and it is reached to the point B. Then in this is we can call it as the shortest distance path length between A and B. This is what? Displacement, and this is actual path. This is we can call it as a distance. So distance is nothing but we can write as a pi r, and displacement is nothing but whose radius, if it is be taken as a r, its displacement is 2r. In case again the body coming back to the A, then again it's if initial point and final point are same, then we can say their displacement is equals to 0. So next we can discuss that if it is not in a circular, it is in a circular path we discuss. Now a part of a circle, there is nothing but arc shape is there. Arc shape means suppose if the body is traveled from point A to B, and this is a part of circle arc, and it's subtended an angle theta at the center, and whose radius is r. Then in this case, what is the distance and what is the displacement is. Now here it is a shortest path length is nothing but displacement. So and this actual path is nothing but the distance. If you want to get the displacement in this case, you should be bisect it. And if you bisect it, now it's a right angle triangle, and this angle is also is theta by 2. Now it is theta by 2. Now this distance C to B, this length is nothing but r sin theta by 2, and this is r sin theta by 2. Therefore, totally the displacement is nothing but AB, that is 2r sin theta by 2. Therefore, here you can understand that displacement is nothing but 2r sin theta by 2. And distance means it is path length. Path length means it is the arc length of this sector. The arc length is nothing but we can say is an angle into radius. Then distance is nothing but we can call it as it's arc length, that is r theta. So like this, distance and displacement both you can able to understand. Shortest path length between initial and final points is displacement. The actual path length is called as the distance. Next will be go to the discussion of some few of the definitions you can able to recorrect it again. That is what is velocity, what is uniform velocity, what is speed, what is uniform speed. Once you can recorrect those definitions, already you studied in the board level. Then we will be go to the discussion of what is average speed, what is instantaneous speed, and its applications here. Average speed. So average speed, nothing but average in the sense it is total distance traveled by the body to its total time interval. So average speed we can call it as a total distance traveled to the total time. If suppose S1, S2, S3 are the distances covered in time T1, time T2 and time T3, then average speed you can write like this: average speed equal to total distance, that is S1 plus S2 plus S3 by the total time interval is T1 plus T2 plus T3, and its units are meters per second. Here, one more point here. So this is for the long time interval we taken. If this time interval is very short, then if the time interval is infinitesimally small, then we can say that velocity is called as that speed is called as the instantaneous speed. So instantaneous speed is nothing but the speed at any instant of time. Otherwise, the limit of average speed as the time interval is infinitesimally small. If the time limit is very small, means we will discuss it, instantaneous speed, the time interval is delta t tends to 0. So average speed when the time interval is infinitesimally small, then we can say that speed is the instantaneous speed. So instantaneous speed you can write like this: limit delta t tends to 0. If the displaced distance is covered is delta s in the time interval of delta t, this we can write to the ds by dt. This is we can take it as a instantaneous speed. And average speed in few of the cases, how it will be there, we will be discussing. First case in average speed applications here, if the interval is divided into equal time parts. If the interval is divided into equal time parts. Let us take, if a body is travelled from A to B. A body is travelled from A to B. And how much of time taken to travel from A to B is, let us take as time t. In this, if your time interval is divided into n parts, then it is t by n. In this first t by n time, the body is traveling with a speed v1 and the distance covered is length l1. The same way, next t by n time, the body is travelled distance l2 and the speed is v2. Like that, if it is making its journey, then we can say the average speed. The average speed, how can we say here is, average speed is equals to total displacement. Here total displacement is nothing but total L1 plus L2 and so on, we can write as a Ln, and here Vn. Then we can write the average speed here is the average of the speeds in this case, that is V1 plus V2 plus V3 and so on, Vn by n. So the average speed is the average of the speeds when you divide the time into n parts. Let us take an example. If a body travels first half of the time, if a body traveled A to B, let us take, it is a time t seconds. First half of the time means the t by 2 time, if it is doing the journey with a speed v1, and the remaining t by 2 time, if it is doing the journey with a speed v2. So here this is the case, belongs to this one only. Just we discussed here equal time parts. Here also the total journey is divided into two equal parts. Here we did in unequal parts, here we did here two equal parts. Then average speed. Average speed means here two equal parts means you can write average speed is equals to, that is v1 plus v2 by 2. Let us take an example. If a person walks 2 meters per second for first 1 minute, if a person walks a speed of 2 meters per second for first 1 minute and runs with a speed of 4 meters per second for next 1 minute. For next 1 minute. So here you can understand here equal times. And first 1 minute he is traveling with a speed of 2 meters per second, and second 1 minute he is traveling with a speed of 4 meters per second. Then you can say the average speed you can write for this case is just average of these two speeds, that's it. When the time is divided into equal parts, then we can say here 2 plus 4 by 2, that is 3 meters per second is the average speed. So you can understand when the time is equally divided, the average speed is nothing but the normal average of the speeds, that's it. Then we can go for the next case. If the interval is divided into equal time parts, we discussed it. Now we will go to the equal length parts. Now equal length parts. If the time interval is divided into equal length parts, suppose if the body is traveling from point A to B, and this total length of the journey is L. Now we are dividing the length into equal parts. Let us suppose first L by N distance, it is traveling with a speed V1, and time taken for that is T1 seconds, and the next L by N distance is traveling with a speed V2, and the time is T2. The same way the last L by N distance is traveled with a speed Vn in the time Tn seconds. So in this case, what is the average speed? So if the length divided into equal parts, what is the average speed is? The average speed is equals to, we can say as a, here in this case, length equal divided into parts means in this case we can write as a 1 by V1 plus 1 by V2 plus and so on 1 by Vn. If average speed in the case of length divided into equal parts means that is n by 1 by V1 plus 1 by V2 and so on 1 by Vn. Let us take here one case, simple case here. If a body is traveling from A to B, let us suppose. In this, first half of the total length is L. In this first half of the distance, means L by 2 distance, it is traveling with a speed V1. Next L by 2 distance, it is traveling with a speed V2. And first L by 2 distance is traveling with in the time interval T1, and next L by 2 distance it is traveling in the time interval T2. Earlier we discussed the time divided into equal parts. Now we are discussing the distance, the path will divided into equal parts. In this case, what is the expression we have? Average speed means n by 1 by V1 plus 1 by V2 and etc. 1 by and so on 1 by Vn. Here, now the path will divided into two equal parts. So n place we can write as a 2. If you write n place 2, then average speed is equals to, here we did two parts, that length, then n place here we can write 2 by 1 by V1 plus 1 by V2, then average speed equal to 2 V1 V2 by V1 plus V2. So example you can understand. Suppose a train started from station A to station B, and it is while it is going from station A to station B, it is moving with a speed of, for example, here a train is there, here P taken, here Q is taken. A train starts from point station P and going towards the station Q. while it is going, it is traveling with a speed of some 40 kilometers per hour speed, and again it is returns back from station Q to station P. While it returns back, it is maintaining the speed 60 kilometers per hour. You can understand here, it is where it is going P to Q, it is gone, again coming back from Q to P. So in both the journeys it travelled equal distances. So equal lengths you can also understand. So equal length parts means average speed, we have the formula 2v1 v2 by v1 plus v2. Here v1 is 40 kilometers per hour and v2 is 60 kilometers per hour. Then we can understand the average speed in this case, length divided into equal parts, then average speed equal to 2v1 v2 by v1 plus v2. That is 40 plus 60. Then you can understand it is 48 kilometers per hour. So like this we discussed equal time parts and equal length parts. Equal time parts, the average speed is v1 plus v2 by 2 in, if you time divide into two equal parts, and equal length parts means if you divide it to two equal parts means 2v1 v2 by v1 plus v2, or else more than that means we can use the generalized formulas. So let us take one more example. If a body travels from A to B and covers a total distance S. In this, first 2/5 of the distance it is traveling with a speed v1 in the time interval t1, and the next 3/5 of the distance it is traveling with a speed v2 in the time interval t2. So the previous cases we discussed equal length part, equal time parts, but here the distance is not equal parts. Then we can follow the general procedure only, that is total distance by total time formula for determining the average speed. So average speed equal to total distance here. Total distance is yes, and total time. Here time t1 means here we can write as a time is equals to distance by speed, that is 2s by 5 v1. And also here the time t2 is distance by that is distance 3s by speed v2. This is the total time. t1 plus t2 is the total time, and average speed means we can write as a total distance s by total time is t1 plus t2. Then you can solve this one by substituting a by here 2s by 5 v1 plus 3s by 5 v2. Then we can simplify as a 5 v1 v2 by 2 v2 plus 3 v1. This is the average speed if it is the case like this. Next, let us suppose one more example. Here a body is traveling from A to B, and the total distance let us take as a S. In this, first 1/3 of the distance, is S by 3. It is traveling with a speed v0 in the time interval is t1. The speed v0 and the time interval is t1. And the remaining distance is nothing but 2s by 3. So how it is finishing the remaining distance 2s by 3 is in this distance it is traveling. Let us take the total time taken to cover this distance is t. So the body is traveling in this first half of the time with v1 speed, next half of the time with v2 speed. So in this t2 time, first half of the time t2 by 2 with a speed v1, the next half of the time t2 by 2 with a speed v2. Now what is the average speed? So average speed means it is the total distance by total time. Total distance is S and total time. Total time in the sense, here we can understand first part of the journey and second part. In second part, the time is divided into equal parts. Then we can say here, distance, first part, S by 3 is equals to velocity into time. What is the velocity here? V0 into time is T1. Then we can write T1 is equals to S by 3 V0. And the second half of the journey, you observe it is time divided into two equal parts means here distance is equals to average velocity into time when the time is divided into two equal parts. Then what is the average velocity in that case? 2s by 3. Average velocity of time divided into two parts means it is normal average of the speeds, that is v1 plus v2 by 2. What is the time here? t2. Then t2 equal to, we can write as a 4s by 3 v1 plus v2. Then you can find the average speed. So average speed equal to total distance is s by total time t1 is s by 3 v0 plus t2 is 4s by 3 v1 plus v2. Then you can calculate this as 3 v0 into v1 plus v2 and divided by v1 plus v2 plus 4 v0. So like this you can also find the average speed in this case. Next will be go to the So these are the cases we discussed on basis of average speed. Next, average velocity and what is the average velocity and what is instantaneous velocity. We will discuss and the examples on that also. Here, average velocity so average speed, total distance by total time, in the same way here average velocity means it is the total displacement by total time interval. You can say as a average velocity is equals to total displacement by total time. What is total displacement in the sense? We know from initial point to the final point, the shortest straight line path is total displacement to the total time interval. And in this case, if the time interval is very short, that is infinitesimal is small, then will be discussed that instantaneous velocity. Instantaneous velocity. So instantaneous velocity means if the time interval is very short, then we can say instantaneous velocity equal to the limit delta t tends to 0. If the displacement is ds bar by dt, means we can write as this is ds bar by dt. This is what velocity at any instant of time. Next will be go to the discussion of an example. So both standard average speed and average velocity, how to calculate it. On basis of an example, we can discuss that. Let us take, if a body is traveling in a straight line path and its position at any instant of time is given like this. x is equals to 8t square minus 3t cube. Then you have to find the following problems here. What is that here is, what is the instantaneous velocity at instantaneous velocity at time t equal to 1 second. Instantaneous velocity, instantaneous velocity is nothing but the rate of change in the displacement vector. Here the displacement is nothing but x, that is equal to 8t square minus 3t cube. Then instantaneous velocity v equal to, you can write as a dx by dt. Then we can differentiate with respect to time, means it is 16t minus 9t square. Then you can at what time you want it, means the time interval is time is 1 second. Then if you substitute t equal to 1 second in this, so last year time t equal to 1 second is nothing but 16 minus 9, that is equal to 7 meters per second. So this is the instantaneous velocity at time t equal to 1 second. Next we are going to find it out at what instant and position the velocity is 0. At what instant and position the velocity is 0 is, so we know the velocity expression here. At instant and position where velocity is 0, where velocity is 0. So instant and position where velocity is 0, how can we find here is? So the given expression we know from that the velocity v equal to dx by dt, that is equal to 16t minus 9t square. So velocity is 0, nothing but here 16t minus 9t square is 0 in the sense you can understand that t into 16 minus 9t equal to 0. So at what time the velocity 0 means at time t equal to 0, or else another point is the time t equal to 16 by 9. So at these times what happens here, velocity is 0. And the position, what position in the sense with respect to times, if you substitute in the given expression, then you can able to know at what positions the velocity is 0. So the position is, if you substitute t equal to 0 in the given expression, that is x at time t equal to 0 is nothing but we will have 0. Means at time t equal to 0, if you substitute it in that, so at initial position velocity is 0, you observe. Next, at another time where the velocity 0 is, that is 16 by 9 seconds. If you substitute the x at time t equal to 16 by 9, then if you substitute that and calculate it, 16 by 9 whole square minus 3, 16 by 9 here whole cube, then we can get 8.43 meters. So at 8.43 meters at initial position, the velocity of the body is 0, we observe. Next we have to go for what is the average speed and what is the average velocity. During some interval we will be discussing the same case. Now the same will be continuing here. The third one is average speed during time 0 to 4 seconds. 0 to 4 seconds. So average speed means total distance travelled by, here total time. So total distance travelled by total time, how can we discuss here is, let us suppose before solving this, we are writing the expression here, total distance by total time. Total time means we know it is 4 seconds, but total distance, how to calculate it, we have to find it out first. Here we observe where the velocities are zeros. First you have to observe that point. Velocity is 0 initially at position 0. Velocity is 0 at position 8.43. Let us take the journey of the body. Here, initially, this is initial point. Initial point means x is equals to 0. Here velocity is 0. Then it is started journey. Started journey. So it started journey, and here where the velocity is 0 is at 8.43 meters. Here velocity is 0. 0. So velocity is 0 here, and again at velocity is 0 at 8.43 meters. Now we have to find what is the distance in the 4 seconds. Distance 4 seconds means in this, what happens here, the body again returns back. So in the body after 8.43, again the body returns back. Returns back, how much time it is traveling means 4 seconds. So what you can write here is distance covered in 4 seconds, in the sense that is, we can find it out by taking the expression x is equals to 8 t square minus 3 t cube. If you substitute 4 here, 8 here, 4 square minus 3 4 cube. So after finding this, we can observe it. It is around 140, 128, and here minus 192. That is here minus 64 meters. Then you can observe this is the initial point. And minus 64 meters, it is traveled in what time here means 4 seconds. So you can understand it is not going forward, it is returns back. And returns back and going along the negative x-axis side to minus 64 meters. Then you should not extend in positive x-axis side, so you should understand it is traveling in the negative x-axis side. To what distance up to here is here. This is the final point. Then it is returned back. Returned back means it up to initial point, it is again covers 8.43, and from here onwards it is covering minus 64 meters. Then totally what is the path travelled by the body is 8.43 plus 8.43 and 64. Only magnitude we have to consider, but we are calculating the distance. So total distance we can cover. So total distance is nothing but we can find it out as 8.43 plus 8.43 plus path length only we are considering. We are not taking the sign here, 64. Then here around 80.86 meters. Then average speed you can calculate it as a total distance by total time. Time interval is 4 seconds. Then it is 20.2 meters per second. So you should understand that here why we are taken like this means at 2 instants the velocity is 0. So at the 2 instants where the velocity is 0, till velocity is 0, the body traveling from x is equals to initial point to the 8.43 meters. From there, if in 4 seconds, it is going to minus 64 meters. So that is nothing but it is returns back and moving along negative x-axis side up to minus 64 meters. Then total path length we calculated, that is we have 80.86. Then if you divide with the total time, we get around 20.2 meters per second. This is the average speed. But in this simple thing, if they ask you average velocity means what? Here we can distance case we take the total path length. But average velocity case, here only this is initial point and this is the final point. This is only the what? Displacement. And this completely is distance. The displacement is nothing but how much here? Minus 64 meters. Then average velocity if they ask, just what you can calculate here is the same case. Average velocity they ask. So total displacement. Total displacement means from initial position to final position. How much it is? Minus 64 meters. So average velocity is minus 64 meters to total time interval. What is the total time interval is? Nothing but 4 seconds. So average velocity is nothing but minus 16 meters per second. Because we know velocity may be positive, velocity may be negative or 0. Because displacement is positive, negative or 0. Same, that's why average velocity also may be positive, negative or 0 also.